So we were lazy and sort of did a poster, and we also have something in CryptPad. If we actually open up that, we actually put everything into the GitHub.
It's been merged in.
Oh, sweet. So there's the visual among us, and then we also have everything in text. So I think I'm sort of new to scaling.
You're most visible in the middle.
In front of the.
He has a separate stream of screens.
Oh yeah. All right. So really, I think we talked about the current state of the DHT. The example that I certainly well known in the last couple of days has been IPFS issues for publishing and resolving, and the issue about who's DHT and how do you scale that. So we talked about messaging protocols as well as this idea of scaling it. Right now with like PeerPad, you're stuck to maybe scaling it to about 30 or 40, maybe a few hundred users. And so the issue also is there are multiple, I think, connections. So you're limited by the connections, and this is what we were talking to Pierre about, I think, is that basically right now with the his issue is that he's limited to about 30 peers. But so the idea of basically taking state and being able to report state as an IPLD object and integrating it, signing it, or integrating it, and creating a proposed state for conflict resolution, and then report it back as far as any conflicts. Also, the idea of actually doing a calendar hash that basically, if this is a detached node, an IPLD, that's an old state is using that how this is actually inject at this time point, and then a voting mechanism to do that. So some of the problems certainly is that DHT nodes can be flooded. There's an issue about membership of DHTs. Basically, how the IPNS was able to scale from Kyle was spinning up a bunch of extra protocol labs nodes in the cloud. But the issue is like, how does that scale to millions? And so if Protocol Labs actually spins it up, but why would I trust OpenBazaar's DHTs over Protocol Labs? So the idea of being a trusted supernode actually came up, and how do you actually manage a trusted supernode? Well, that's verifiable claims. And that's something I know about. So that also the issue about flash crowds come in and try to populate into the DHT, and the idea of actually basically how to self-heal. You're then contributing resources to the DHT until it actually propagates, and being able to have some way of visualizing that network so that you can actually get some feedback or the state of the network as it's self-healing and auto-magically scale back. So some of the solutions we proposed was the idea of proof of work, that as you push things to the DHT, you have to solve some cryptographic function, coordinate with signals, so that's messaging, gossip, basically I was talking about gossip, basically, again, gossiping about the network state as an IPLD object concept, CRDT, and signing it and gossiping and actually like reporting back the gossip about that subnode. And then that's using IPLD for that state. Reputation systems, so basically if this proxy is not known and it's trying to sign things for a whole bunch of new peers and it's basically spinning up trying to flood the system. Well, this is a new node that hasn't had enough time on the system, so it should be less trusted. Network visualization we talked about. Network recipes. I forget what that was about.
Yeah, so the basic concept is when we end up having a couple like these mesh networks, right, of hey, here's an established network they have, what we want to be able to do is provide recipes for based on the situation that this network is going to be in, so that you can have different configurations of how these kind of sub-networks want to operate, so that it can kind of control how it scales. So if you have kind of your mesh rings and you have this network topology kind of being shared across, as more and more nodes are joining and demands are differentiating, and we can say, oh, you know what, we need to get another DHT scaled up. We're going to go to one of our trusted nodes, tell it to turn into a DHT, and then we can watch the kind of the mesh networks shift in transition. And then over time, as that scales back down, we can change that back. So some of the stuff we were talking about with network visualization and simulation is actually being able to set those recipes, run the simulations, and watch the meshes change.
Yeah, and that basically got to my question for Brian was, Brendan, is the model of the data of the topology of the network. And so actually, how do you represent that and make sure that actually here's the network that we're trying to represent and here's the proposed state for actually the conflict resolution and at what time point. And then lastly, CRDTs for rebalancing that. So I think, David, we also had talked about a couple different things. Do you have anything else to interject? We had a fascinating conversation, though. I think, did we cover everything?
Yeah, there's a lot of these things. We definitely talk a lot about like candidate solutions and like what we could implement first. So a lot of the shortcomings, a lot of the problems. It all comes down to give better primitives for applications to like give hints to a peer-to-peer of what they need. So when we talk about membership, when we talk about membership management, is really, okay, like I'm a peer path and I'm just really interested in talking with nodes that are on the same path as I am. So why am I connecting to the rest of the network? And so if there is something that gets exposed by peer-to-peer APIs that can give peer path a way to then give that information to peer-to-peer, then only peer-to-peer can make better adjustments. The other thing is really the coordination protocol, which is kind of like very cheap protocol. Like it's just like nodes telling each other, hey, here's like what I see from the network. It seems that there's a lot of a load or like not a lot of load. Of course, like this can be attacked, like someone can be lying, but at the same time, this is just like to help nodes make better decisions. If some node is telling that like, oh, I see 3 million nodes joining, like we should like calm down and like increase the size of our crypto puzzle, and then like 10 other nodes tell you, oh, I just see 10 nodes joining, then you can like lower the reputation of that node, right? And so you can use all of this to make better decisions. And in the end, like a lot of these networks, like you don't really need more like than 100 to 200 connections. And this is already a lot. Like you can access pretty much the entire network with just like 100 to 200. And in some runtimes, like the browser, we really don't even want to have more than 10 or 20 connections. Otherwise, we might just kill it. So yeah, like I guess I'm just like repeating stuff now. But here's some of the conclusions.
All right, questions. Other questions?
This reminded me a lot of Coral, and so great that you are looking at it. I think there's a whole area of protocol design to be explored there on what these self-organizing clusters should do. One part is routing, and Coral, that's what Coral does, but there's a whole bunch of other stuff that could happen, which I think you're starting to uncover. I would worry about, with a lot of these systems, you have to get a really simple construction for how these systems grow, merge, split, come back, and that has to be kind of pretty stable once you ship the same protocol to like millions of nodes. And so I would say like reducing the complexity of that is important. And so I think coming up with very simple ways in which these clusters form or these subnets form and how they do something different would be important. But just more of a design thinking thing.
Okay.
Okay, one of the things that multiple groups discussed, and we talk about a lot about having fun. So one thing that we really want to have, and multiple people got excited about it, just have a contest. Like, let's create a primitives that let multiple people build different topologies, and then let's come up with all of these use cases like live streaming and like forums and blogs and social networks, and like just let people go wild. Like, let's create a huge contest. It can be in person, it can be online. Invite the research community, the hacker community, the peer-to-peer community, everyone just like to try different things and try to find the best strategies so that we can then have recipes, right? Like the thing that we started seeing is like, oh, maybe like we'll never find a one-size-fits-all solution unless we ML like all of this. But we can definitely come up with multiple solutions that are really good for some use cases, and then people can just like pick that from the recipe book and apply. The thing is, we will only know which is the best recipe once we give it for many people to taste it. And so yeah, like let's just like shoot to have a contest like very, very soon, like this year. Like it should be like one of the big goals.
All right, let's make that as a goal for a hackathon at the next meeting.
Yeah,
in Lisbon.
or 3 months from now.
All right, yeah.
Sorry, we have time for one more question, and I saw Cole raising his hand.
Oh, yeah, just echoing Juan's sentiment about like simplicity. I think something that I've like already gotten a bit of feedback about is like the kind of back to the like who's DHT question. Like, oh, should I be running my own separate network, or is there one global network? I know that we tend to focus on like the single global network, and I think to that end, we really do need a way to kind of initially like participate in everything, and then kind of slowly let the things that you don't care about time out and like leave your purview. It feels like something like that, like rather than being like super analytical about what you're involved in and like subscription management, which can get super complicated. Yeah, that just seems like that's like an insight worth carrying forward.
Cool.
The thing that I was thinking about immediately, or not immediately, but throughout the conversation, is that there's a very interesting parallel. One strategy for building some of these things to be much more secure might be to do some like probabilistic checking of a DHT. So you spin up 1,000 nodes or something, distribute them in a ring, and then start, for these kind of reputation systems, system design type of ideas, you can test some things and start trying to figure out whether or not some nodes are misbehaving. And then that coupled with preventing nodes from joining in particular ways can couple well. Like this idea of using a crypto puzzle to delay in coming into the DHT can be very easily subverted. If you have some kind of auto scaling, like if you notice a ton of people trying to do an ongoing attack, then that just poses a problem to participants just delaying their joining and then joining very slowly, acting honestly for a long time, and then attacking the network in one moment. But a way that might be averted is reputation systems. The reputation systems and peer-to-peer pair really well, but nobody has really built one that works extensively well. There's a bunch of problems. I think BitTorrent and Tracker Trust, Tracker peer-to-peer systems, are one of the Tracker reputation systems and BitTorrent ratios were a very good example of this working very well. But that's a few and far between success, or success is very rare compared to the number of times people have tried this kind of stuff. But this might work well with, in general, security is one of those things where you just have to spot an attacker once to be able to get them out of the network. And so if it's expensive to join the network, then reputation systems can work really well. Just random thoughts. Anybody else have random ideas? No clubbing.
So I think just building upon the reputation systems, I think the identity issues and capability systems, I think that the DID spec is actually supporting, and these still are early days for creating a specification. But the idea of basically, I have an identity and I have some nodes that are controlled under my identity that actually are peers. So even though that node is not trusted, I'm trusted. And so that you can tie back ephemeral nodes actually that can scale up back to me as being the source. And so I think, reputation, identity, membership. Other things, there's, I'm still new to, DHTs and how to load balance that. But I think also the structured protocols, actually, the context, I think was what Stephen was mentioning, I think to me, just makes sense. So I suppose the other thing actually I was thinking about was how to, the token economics of that, as far as reputation systems and it doesn't have to be it's a separate one, but I think actually how to make it disincentivize.
I like an extreme micro thought, but just as far as the streams are concerned, I feel like super cheap ephemeral streams are really great as far as protocol design and keeping complexity down is concerned. So go Stephen, go everybody, go. Let's figure it out. Because I can't imagine doing more intense work in the line of pipelining without introducing massive complexity to stuff.
Oh, wait. All right, so I feel a lot of my ideas have been represented here by others, so if I'm being redundant, tell me to stop. But one that I definitely would like to bring is on these reputation systems, it's very important to make sure that we don't leak important information about the users that are using the network. we typically think reputation systems are like the hammer that solves all the problems. They do solve a lot, but they also mean that like they are stateful, right? Like it's something over time, like something that you can start analyzing and like just observing the patterns and like observing where that identity is valid where. And so you need to find another mechanisms to like have reputation but not leak that is the same user. There's some interesting research on that. There's a paper on non-rep that basically is a peer-to-peer anonymous reputation system. I haven't really had the chance to explore the construction in depth, but like a lot of great people talk about it. And other things like constructions just for key rotation and like the ideas around like double ratchet algorithms and just like group coordination, like enabling not only peers to join, but actually letting devices to join in lieu or of other peers. Like, so if I have a group of people and I am talking on a chat room with my desktop, I want to have my phone join that room. And so I can do something like I join, I notify everyone that I'm joining with my device. I prove that the device is mine, but just to make sure that there is no malicious entity trying to force me to convince everyone that another device is joining. Imagine like NSA kind of like adding one device through me to the network. You can have other peers like just check, and that can be through a side channel. Just check that like, yes, the vid is in fact like adding a device and that's fine. So a lot of interesting work on this on things like Matrix and the Mega Ohm protocol. It's also super interesting. What else? Yes, I'm really excited about network visualizations and like the contest. Like we should totally do a peer-to-peer, like scale to millions contest and like see who gets there first, or every year just like get a little bit closer. What else could I say? I think that's it. Thank you. Any more?
One more comment just to follow up on that.
Let's keep bossing ideas.
It's just, so the issue about correlation, we've talked about this in the DID spec, and what we came up with is ephemeral identifiers, and so which are pairwise. So this is why ED25519 is actually critically important, is actually you do the Diffie, or something like a Diffie-Hellman key exchange, and you get to a prime number which represents the pairwise association. And that itself is actually the token to move forward. So actually, those are pairwise, so they actually will never be reused unless in the same relationship.